algebra students, Mr. Lawrence here with your flip lesson, and we're going to say after today's video, I can solve rational equations. Now, if we had an equation like this one here, this is kind of weird to work with. I mean, the fractions make things ugly, right? Well, when I'm solving, if I can get rid of my fractions, I make this problem a lot simpler. Now, what operation is implied in a fraction? Division, right? So I'm going to use multiplication. In fact, I'm going to multiply this term and this term and this term all by the same number. What number do you think I'm going to do? Well, that number is going to be my LCD. And sometimes you have a hard time determining the LCD. Well, I'm going to show you an easy way to do it. I'm going to look at this fraction here in its denominator. I know for a fact I need a 2 in my LCD. And that 2 represents him right there. All right. Now, here I need a 3 in my LCD. Right? I need a 3 to be in there. Now here the denominator is a 1, so I don't need to put it over there. So my LCD, the smallest number that all my denominators divide into evenly, is 6. So I'm going to multiply each fraction by 6 over 1, or each term I should say. Okay, and in this case I'll just multiply by 6. And we've done things like this before. I showed you, Mr. Lawrence was setting you up for success, months ago. All right, so when we multiply here, 2 goes into 6 3 times. 3 times 1 is 3. 3 times x is 3x. Look at that, there's no fraction. All right, here, 3 goes into 6 2 times. 2 times 5 is 10, times x, 10x. 5 times 6, that's a hard one, 30. Now I'm going to combine my like terms and get 13x. 30, and it's a one-step equation from this point. I'll divide by 13. Okay, so x is going to equal 30 over 13. And remember, I know one of your elementary teachers might have told you that you can never have an improper fraction. Just tell me who it is, and I'll send the salami truck to their house this summer. Okay, if you wanted to turn it into a mixed number, you could say 13 goes into 32, and I think there's going to be 4 left, 4 thirteenths. Either one of those answers is acceptable. Okay? If you wimp out and go decimal, I won't get too upset, but I want you to stay fraction at least until the end. Now, a problem like this is very much the same thing. The only difference is you're going to have to do a little factoring before you get your LCD. So I see that I have this x squared minus x term, and it can be factored. So I'm going to factor it by pulling out a GCF. All right. Now I'm going to look for my LCD. I'll bet you Ashley can tell me one number that has to be in my LCD. And I'm hoping she's going to say X. Well, X will cover this one, and it'll cover that number. It can, when it's written over here for the LCD, it can represent itself one time in every denominator. Now, I'll bet you Dylan can tell me X minus 1. Well, that'll represent him and him. Now, are all my denominators represented? Sure they are. Now, I actually like these problems better than the adding of the expressions because just like I did in the example right above this, I'm going to make these fractions disappear. I'm going to multiply each term by the LCD and watch what's going to happen. I think this is pretty cool stuff. Okay, so I got this one. All right, so my LCD is x times the quantity of x minus 1, right? Okay, so I'm going to need that here, here, and then one more time here. Okay, and if you want, you can put those all over 1. That's fine. If it helps you, visualize numerator and denominator better. Now watch what's going to happen. Okay, and this first fraction, I can see that I have a number of x and a number x here. They can cancel out. I'm left with x minus 1 times 1. Well, that's just x minus 1. In the second fraction, the x minus 1's will cancel, leaving me 1 times x, or just x. In the third one, this is one I call the hard one, x will cancel with x minus 1 with x minus 1, and that's 6. X and x is 2x. Now it's a two-step equation. It's a linear equation, so I just solve it. Or if it was quadratic, I'd have to use the quadratic formula. 2x equals 7, divide by 2. X is going to equal 7 halves, or you could tell me 3 1/2. You don't have to tell me both. Okay, if you're feeling rather wimpy, you could tell me 3 5/10, 3.5. All right, see how simple that was? First thing I do is factor. Looks like that can factor to x plus 2, x minus 2. Now I get my LCD because all the denominators have been factored. These two don't factor. Well, I need an x minus 2 in my LCD. And every time I put the number over here, it represents itself one time in every denominator. Then I need an x plus 2 in my denominator. Represents him, represents him. Everything's represented. Now I can go ahead and multiply by x plus 2, x minus 2. That's all in the numerator. So I'm going to take that, I'm going to clone it, because I'm going to multiply that one, and that one. And maybe I can do this. Make it look a little bit better here. Turn off that infinite cloner, and I can move them over here. And I'll put them all over 1, just so it looks a little bit better. All right, now I'm ready to do some canceling. Oh, there's an ugly color to cancel with. Looks like the minus x minus 2's will cancel, and I'll be left with 5 times x plus 2. Wouldn't that be 5x plus 10? And here are the plus 2's and the minus 2's, and I'll be left with a plain old 3. And over here, the plus 2, x plus 2 will cancel, and I'll get 15x minus 30. All right, my like terms are these two, 13, so I have 5x plus 13 and 15x minus 30. All right, I'm going to subtract 5x from both sides, and I'm going to get 13 equals 10x minus 30. Add 30 each side, and I'm going to bring my work over here, and I'm going to get 43 equal to 10x. Going to divide by 10, and x is going to equal 43 tenths, or you could say 4 3/10, because 10 will go into there 4 times, and it'll be 3 left over, or 4.3, 4 3/10. Okay, going to do one more. Going to do it kind of quick because I think you're catching on. First, I looked factor. X times x minus 4. I don't see anything else that'll factor. Okay, go looking for my LCD. Gonna need an x. Shoop, shoop. Gonna need an x minus 4. Shoop, shoop. Got my LCD. Gonna multiply everything by the LCD. So I've got an x times an x minus 4. Got an x times an x minus 4. And I'll have an x times an x minus 4 here. All right, getting ready to cancel. There we go. That's a nice color to cancel with. X minus 4's will cancel, leaving me 7x. Here, remember in the other problems where we had a negative, we went boom, boom. Gonna do that. The x's will cancel, and now I have to distribute a negative 3. So I'm going to get negative 3x, and negative 3 times negative 4 is positive 12. Okay, last ones. X's will cancel, x minus 4's will cancel, and I'll get 12. Combining my like terms, I get 4x, subtracting 12, subtracting 12, and I'm going to get 0. I'm going to divide by 4. I'm going to divide by 4. X is going to equal 0. Now there's a problem here because what happens in this fraction right here? It was 3 over x, right? What happens if x is 0? This is undefined. You can't do it. So this problem actually has no solution. It doesn't have no solution just because I got a 0. It has no solution because my solution for x ended up being one of the restrictions. Now I know I didn't find restrictions on these. I don't need to, but I have to make sure my answers don't match the restrictions. So x minus 4 implies that x cannot be 4, right? If I had found out that x was 4, I would throw that solution away. X equals 0 for this fraction here. Well, x cannot be 0. If it is, the fraction turns to an undefined thing, the denominator 0. On this previous problem here, I got x to be this number. Is that a restriction for this quantity? This or either of these? No, it's not. That's why I didn't throw it away. Okay, up here I got 3.5. Is that a restriction for x? No, it's not. Sorry about that long pause. I was fighting off a sneeze. This country air is getting to me. All right. Anyway, so you have to check your answer to see if it is a restriction. If it is, you throw it away. Okay? So let's pretend we had some denominators like this. And I'm not going to do the whole problem. We're just going to pretend. Okay? And we're done solving, and we got that x equals 3, 2, and negative 5. Okay? Now we're just pretending. And you notice the restriction here is that x cannot be negative 5. I would throw that away. This one says that x cannot be 2. I would throw that away. And my only solution would be that. Again, these are not the solutions to this problem. I was just showing you a more concrete example. All right, Mr. Lawrence signing off. Good night, everybody.